Alright guys, it's always harder to do this way, but how does this work? Yeah, 3 to the 10th power equals y. And you can put that in calculator and it gets really, really, really big. So how do I rewrite this? What's the base in this statement? What's the base? 7. What's the power? So it's going to equal W. So 5.6 was the output. It is now the input. So it's always a little harder to rewrite it from exponential logarithm. But what do you do at the end then? You just really quick check. 7 to the W equals 5.6. Yay. So checking it would be easy. And you can pick up a mistake pretty quick. But the base is the base. The output is the input. And the input is the output. That's how inverse functions work.
So when it's in that form, we have to put log in front of the number?
Definitely.
Okay.
That's the only way to keep this statement true. This is true. This is how to write it as true. Be careful, too. This is not 7 to the 5.6, right? I always get somebody read this wrong or look at it wrong. This is log base 7 of 5.6. Can somebody give me an estimate of that? How the hell do I do that? Well, what's log base 7 of 7? What is log base 7 of 7? 1. So the answer to this should be a little bit less than 1. So he had to give like a guess. He'd say 0.8. What the hell? I don't know. I like it. Okay. These are very straightforward here, hopefully, right? How many 3s does it take to get to the center of a tittle? 4. Yeah, 4. So on a test, I'm going to ask you to show me work, and you're going to say because 3 to the 4th equals 81. I don't want people to know a little too much about the calculators and have answers come out of nowhere. I want to see a little bit of thought process. What happens here? Yeah, so I love the people that give me some big decimal number to that. No, come on. Natural log and E are opposites. They kill each other. So what would this be? Also pi. Doesn't matter who's in which. They kill each other. Like it. What about this one? This is just going to be 0. I like it. Anything to the 0 power is 1. I like it. What about these two? Based on what I just said here. What are these two going to do? So the answer is 4.
Because there's like a...
Understood what here? 10. So the bases match, so they kill each other. So if I had 10 to the log base 7 of 4, I can't do shit with that. The bases don't match. So they're not opposites. They won't kill each other. It's like me saying, what's the 7th root of x to the 5th power? I can't, nothing happens. I can rewrite it, but it doesn't make it solved, right? Can't do. But if this is the 7th power, they match, they kill each other now. Same kind of thing. And this one we already did. I just want to keep doing this one. We kind of did this one. We did log base 2 of 16. So log base 16 of 2 should be the inverse of that. That's kind of freaky. So let me show you a different way to do this kind of problem. So the very straightforward way is the number inside is less than this, but bigger than 1. So the answer has to be a fraction. It's got to be a radical. What root of 16 is 2? The 4th root of 16. But let me give you a different way to look at that before we do the rest of this. And this way is kind of funny because the first step is admitting that you have no freaking clue. What is the answer? We don't know. Okay. How can I rewrite this? 16 to the x equals 2. All right, now watch. This is way too cool to believe. You guys semi with me? Here, I'll let you go. So you're like in the same room. Quick side note. What if I said 3 to the x equals 3 to the 5th? What the hell's x? What's x? 3 to the x equals 3 to the 5th. X has to be frickin' 5, right? You guys with me? So if the bases are the same, this kind of question would be easy. Are the bases the same? Shit, no. But what is 16? 2 to the 4th. We put a little 1 there. We know there's a 1 there, right? So then what's got to be true? If 2 to the 4x equals 2 to the 1st, that means that 4x equals 1. So what's x?
5 by 4.
Holy shit, that's exactly what we got. That only works, obviously, if the bases can be made the same. If I would have made this a 17, this whole thing goes to shit, but that would have been a really mean question in the first place. I wouldn't give you one like that. Then I'm like, do this by hand. Maybe. I know. But every time you're doing these problems, remind yourself, logarithms are powers. This is why this kind of process works, because it focuses on what the powers have to be to make this true. Because that's what a logarithm is asking. Okay. So let's see what's left here. There you are. Oh, no. Based on that answer. Well, sort of based on that answer. This is a little, what's it say, 1/2 inside? Yeah. Based on that answer, perfect. 16 to the 1/4 is 2. This just wants the answer to be flipped. So what has to happen to the power then? It's the same power to make it 2, but then I have to flip it. I really want you guys to see this. -1/4, yeah. What's log base 3 of 9? What's log base 3 of 9? 2. Because that's the power 3 needs to become 9, right? So what's log base 3 of 1/9? -2, because I just take the answer and flip it. So if you ever see like a 1 over something in your problem, just kind of do this, figure out that, and then make it negative that. That's what would make it flip. So 1/4 power makes this become 2. How do I take one more step and make it become 1 over 2? Is make it a negative power. That would make it become 1 over 2. It would flip it around. Generally bad at poker, but as always, I would never play any of you poker. Most of you like that. Okay. Good Lord, that's strong. Too strong. Oh, yeah. A G should be, I don't want to say this too early, but it really should be easy by now, right? What's that? 8. Yeah, it's canceled. 8. 8 left alive. Or, what does B need to become B of 8? It needs an 8. That's amazing. So what about this guy? What's the one little difference between this one and this one? It's written in root form, which of course, now that you guys have all taken me, you're going to have a little thing against roots. Don't. They're out there. They're out there. But it is the dumber way to write it in general. So I'm going to rewrite that radical as what? 11 to the. Then this becomes a silly, easy question. What's the answer? 1/2, because those kill each other. So if you write the inside as a power on the base, the answer is quick, because those two things cancel. You just get whatever the power is. That's another reason why something like log base 3 of 27 is 3, because 27 is 3 cubed. These kill each other. There you go. Doesn't really change the work, but it just is a different way to look at it. Okay, maybe. And then the last 3 were on the calculator. Let's see how you guys did. What's 3 to the 2.16? 10.73? Because I asked you to round to the hundredth place. I like it. What's natural log of 111? Say again?
4.71.
4.71? Sounds about right. And then finally, log, what was it? 0.4132. Negative point 38.
Yeah.
We got dissension in the ranks. Well, my calculator's out there, so.
Yeah, 38.
So negative 0.38? But you thought it was,
3.16.
oh, positive 3.62? Yeah, so something definitely went wrong there. Because think about it. This is like 4/10 just about, right? So it's like over 10. So the answer should be in negative. It should flip it. But it's not very nice, so this answer is not going to be very nice. We just rounded it to the hundredths place to make it easier to digest. Okay, I like it. Not yummy, but it does go down. Okay. Okay. Oh my gosh. The end of the semester. So let's talk about, now watch this, watch this. We're now going to talk about properties of logarithms. So anytime we learn a new function, we kind of first figure out how the function works, and then we talk about, well, how does it work with itself? What's the algebra of this thing? That makes it sound so horrendous, but let me try something out. I'm going to try to be, all right. I think I figured out how to say this stuff, so you guys can stay with me. Let's say that x is b to the m. Oh, that's already yummy, isn't it? Oh, well, I can't. Just stay with me. Try to. And y is b to the n. You guys, is that cool? Okay, now watch. What is x times y? True, but knowing what they are. So what's x times y? B to the n times b to the m, which is? B to the... No, we know better than that. What do you do with powers when you multiply like bases? Add them. So what's this? Okay, names. All right. So this is the big thing. Since logarithms properties are the same as exponents properties, the better you remember and know exponent properties, the easier log properties will be. They won't be easy because they're going to be written in weird-ass log form. But I desperately want you guys to realize logarithms are just powers. So tell me, what happened to the power? What happened to the powers when I did x times y? What did the powers on these two do? They added. So the power on xy, the power on xy, I want you to realize that's really what that says. The power on b to make xy, let me be careful. The power on b to make xy, what happened to it? When I multiply xy, what happened to the power? It added. What was n? N was the power on the y piece. Let me do this in the right order. What's m is the power on the x piece. And n was the power on the y piece. Oh shit. So all this statement says is when I multiply things with like bases, I add the powers, because logarithms are powers. Let's try an example, a concrete example to get a better feel for this shit. What if I had log, what do you got, Jeff? You can do it, man. log base 10, yeah, let's do something like that, of 10 times 100. Let's rewrite what this would look like using this property. What would it look like using the property? Log base 10 of 10 times 100 equals log base 10 of 10 plus log base 10 of 100. All right, I like it. So basically what it's saying is, if I have a product inside, I can make it a sum outside. The log of a product is the sum of the logs. Okay, like if you just told somebody in the street that, they would slap you and walk away, so they stay away from your logs. Let's check this out. Let's do this side first. What is log base 10 of 10? And I'm being really nice writing that base 10, but oh well, I can deal with that a little bit better. 10. Careful. Log base 10 of 10 is 1, because I just need one 10 to make 10. What's log base 10 of 100? How many 10s multiplied by 100? 2. So I better get 3. Let's do this one directly. This is log base 10 of 1,000. What's log base 10 of 1,000? 3. So I'm hoping that some of you guys realize on one level this is kind of silly. Of course the answer is going to be adding those two together, because that's what's going to happen with the powers. I'm just going to add them together. So watch what we can do now. Watch what we can do. We're just getting stronger. Stronger. You're just getting more and more stuff thrown at you. So if I said log base, what do you got, Jim? 5 of 50 plus log base 5 of 1/2. Neither one of those, I can't do either one of those, right? Log base 5 of 50, how many 5s does it take to multiply to be 50? I ain't got a clue, man, I can guess. Log base 5 of 1/2, even worse. But what's the property say? Do it the other way. So the property says log base b of xy plus log base b of x plus log base b of y. So don't I have this right now? So it equals this.
Is that the formula that I'm always going to use for that?
That's the property of logarithms. It's always true for logarithms, always. If I have the sum of two logs with like bases, I can consolidate them. When do I add powers? When I was doing what? Careful. I add powers when I was multiplying. We know that. That's how to remember this property. That's what this property says. The powers here are being added. When do we do that? When I was multiplying to begin with. And this whole idea of consolidation, it should make sense. That's the actual way we normally use that property, is to put stuff together. So here I'm going to get what on the inside? 50?
Plus 1.
No.
50.
Times, yes. That's the whole idea. When do I add things with like bases? When do I add powers, sorry? With like bases? When I was multiplying this stuff. That's what that property says. This is how I can rewrite some algebraic expression with logs. I can consolidate all my plus stuff like this. And what is half of 50? And what's log base 5 of 25? Well, how many 5s does it take to multiply to 25? 2. Not what's 25 divided by 5. We don't need another symbol for that. We already have a couple. Right? We have this, and we have this. My God. Right? We don't need another one. So this is, how many of these does it take to multiply to be this? 2. Or what power does that need to become that? Second part. Okay. So it should make sense. If this is one property, what do you think happens in this case? When I divide things with like powers, what do I do with the powers? I mean, like bases. What do I do with the powers? Subtract. Okay. Now these two, don't get me wrong, everybody always hears me wrong. These two are really important. But the one I'm about to write down is in some respects more important than either of these. I'm going to use a different color. Just write it like that. All right. Oh shit. All right, let me show you what's going to happen with this. What does this inside mean? So how many x's?
Yeah.
M of them. I love it. Go with me now. Some guys are like, you lost me when you came to the door. Shit. I can use this first property over and over and over and over again. So it becomes log base b of x plus log base b of x plus log base b of x plus log base b of x. How many times? Is everybody with me? What do you do when you multiply the inside? You rewrite it as log base b of that thing plus, and you just keep going. If I had a whole bunch of stuff that had all the same base, what would I do with all the powers? I'd add them all up. How many of these are there? See the little dot, dot, dot? How many of these are there? No. M. How many times do I have to do this? M times. This is M frickin' X's. Why were there M frickin' X's? Because that's what it says. I know you guys love this. But just break this down. X to the M does mean a string of M X's. Are you with me?
Yes.
Let go of M not being a number. Yes, it is. I just don't know what it is. If it was 2, it'd be a string of 2 X's. If it was 118 billion, a string of 118 billion X's. Right? Whatever the shit it is, that's how often this is going to show up, and that's how often I'm going to write this using the property. So what's a better way to write something that adds to itself M times? If I add 2 to itself 28 times, what do I get? What's the quick way to figure it out? I just said the word, actually. This is where the word times comes from. 28 times 2. If I write 2, if I add 2 to itself 28 times, the answer is 28 times 2. So if I add this to itself M times, the answer is M times this. Let's see why this makes sense. What do I do with powers when I have a base raised to another power? So like, what would I do with these two powers? What do I do with the powers? Multiply them. So when I have something raised to a power raised to another power, what do I do with the two powers? I multiply them. Right? It'll be that power times that power. And the way we kind of use this, all right, that is the most important one. Let me show you this, why this is true first, and then we'll try another problem out, and then we'll probably call it a day. So this first problem you can use, let me just remind you, how would I do this? Let me see if you guys can figure this out from what we did earlier. I can only do this kind of problem if I can make the what's the same. The base is the same. And what are they both based on? 2. 4 is 2 to the second, and there's an x up there too, right? And 8 is 2 to the third. So then how can I write the next step? What's got to be true? Yeah, 2x has to equal 3. So x has to be 3 halves. Cool. Now, watch. And I'm going to show you why this property, this one, is the most important. And again, this property, if I put it all in place, log base b of x to the m equals m times log base b of x. What's it look like the m does? It just looks like the m Comes down. That's what it looks like. That isn't what algebraically happens, but that is what it looks like. So that's the shortcut. It just comes down. So now watch. Can you do the same thing we just did with this problem?
They don't have the same base.
Holy shit, 5 and 7 aren't based on anything, let alone the same thing. And where's the x? It's up in the exponent. Jeez, the flip. So if I had a problem that was cube root of x equals 2, of course what would I do to both sides?
Square.
No, cube it. If I cube both sides, it'll free the x up, right? So here, I've got to do something that will make the x get free. It's up top. I can't do shit with it. I need it to be down. If only there was something I could use that would make the exponent come down. And of course, the only damn thing that does that are these logarithms. In fact, let's be smart. Let's use a logarithm that shows up on our freaking calculator, either log or ln. So I normally use ln because there's one less letter to write. That is officially, and most math people will tell you the same thing. You always use ln. One less letter. Over my whole lifetime, it's going to save me a lot of time. So watch this. You ready? Same way I cubed both sides, I am going to take the ln of both sides. I'm doing the same thing to both sides, right? Taking the ln of both sides. Same way, watch this. How would you solve this problem here? I know I keep bouncing around, but you would take the square root of both sides, right? And it's got its own little weird shit. So here, what do? I take the ln of both sides. This is not ln times 7. That doesn't make any sense. I wouldn't say square root times x. No. Square root of that. Square root of that. And there's the weird little plus one. So don't think you can divide by ln. You can't divide by the square root symbol. That doesn't make any sense. So what can I do now with this? What's the whole purpose for me doing this? What can I do with that x now? Bring it down. So it's x times this equals that. One step away from knowing what x is. What's with the x I don't want? ln 5. Right? ln 5 is a number. I don't want to write what it is because it would be a decimal that never ends. So I'm just going to keep ln 5. How do I get rid of ln 5? Divide. Careful. Right? The rules of how to solve equations never change. We just learn more stuff. Does somebody help me out? Can you guys? What is ln 7 divided by ln 5? Be really careful if your calculator opens a parenthesis. You better close it. Is this guy still going? You're a trooper, man.
1.21.
So it's about 1.21. Go a little bit further from
1.209.06.
1.209. All right, that's good. Now let's check this. Watch. This is kind of cool. In your calculator, do 5 to the 1.209. It's not going to come out exactly because we rounded, right? But what's 5 to the 1.209? Which is basically 7. So that is the power. It found the power that 5 needs to become 7. If you think about it, since this question is asking what power does this need to be this, it makes sense that we use logarithms because that's their purpose. I kind of snuck into 12.6 there because 12.6 is all about solving equations with exponents, exponentials, and logarithms. Oh shit. Just a lie about what I said a minute ago. One last one here. Logarithmic equations normally are nowhere near as freaky as you might think because they just involve rewriting it in the other form. How do I rewrite this? 3 squared equals x minus 1. Hey, and that's an easy ass equation, right? We kill that log quick. What they're going to do is they're going to have multiple logarithms, and then you do this kind of shit. You collect them, because if you can get it in one log, you can just rewrite it. And then you're done, right? This will be x is 10. 9 plus 1. Maybe. Man, you guys look shell-shocked. Sorry. Okay, so tomorrow is that quiz. What did I say? I think I have it on video from last time. 11.3 to 11.8? That sounds familiar.
Yeah.
So that quiz tomorrow. Oh. Let me give you guys, I went and printed out the practice final just so you have it now. We're going to review on Wednesday and Thursday for the final. I feel like I shouldn't do this if people aren't here. Oh.
This will be on which section?
11.3 through 11.8. So you should have had enough time to get that homework done.